Question number 6 deals with energy stored in a steel rod. So there was energy stored in a spring also. So we need to find K equivalent, that a rod is equivalent to spring. A steel rod of Young's modulus Y is equivalent to a spring. That means K of a rod. This is what we need to find out. Original length of the rod is L. You add some weight, length increases by delta L. Here, when you add some weight, the length increases by say x. Step number 1. K of rod, spring constant of a rod. Young's modulus Y of a rod, yes. Ratio of a stress to strain, longitudinal strain. F is equal to what? F is equal to Y A delta L by L. The restoring force is equal to some constant time extension. For a spring, the restoring force was equal to magnitude only magnitude, K time extension, be it delta L or X. So, from these two, K of a rod is equal to what? Y A by L. 2 minutes with you to write. K of rod is Y A by L. Step number 2, energy stored. Energy stored in a spring was equal to what? 1 by 2 K X, that is extension. K, in this case, K of rod. This was the formula used. K of rod is equal to what? Yes, 1 by 2, yes, Y A by L. Extension in the rod, delta L square. Completed. Step 3. Energy stored per unit volume. That is energy density. Energy stored per unit volume of the wire. Energy stored is 1 by 2 YA L delta L square. Volume of the rod, yes. Cross sectional area is A, this area is A. Length is L. Volume is A into L. What you get is A is cancelled. What you get is 1 by 2 Y delta L square. This is also L power 1, L power 1, L square, that is delta L by L square is equal to 1 by 2 Y. Yes, change in length by original length. Strain. Young's modulus was defined as, yes, ratio stress by strain. If you put this value, Young's modulus Y is equal to stress by strain. The strain cancel. What you get is 1 by 2 stress. So energy stored per unit volume represent a small u. 2 minutes with you to write. Numerical number 12. Page number 7 by 30. Numerical is a wire suspended vertically from one of its ends is stretched by attaching a weight of 200 Newton to the lower end. The weight attached stretches the wire by 1 mm. What is the elastic energy stored in the wire? 2 minutes with you to try. Given is what? Force. How much? 200 Newton. Extension delta L 1 millimeter 10 raised to power minus 3 meter. Try. Treat a rod or a wire equivalent to a spring. Energy stored is equal to what? Energy stored in a spring is equal to 1 by 2 K extension square. 1 by 2 K into extension Kx. You may term this as Kx or Kl into extension. This part is equal to what? Force is equal to K time extension. Restoring force is equal to K time extension. So it is 1 force, extension is delta. It is 1 by 2 spring chapter. 1 by 2 Kx square. Kx is equal to what? Force. X is extension delta L. Force is given how much? 200. 1 by 2 force is 200 into delta L is 10 raised to power minus 3. What you get is 100 into 10 power, that is 0.1 joule SI units. Numerical number 13, 1, 3. Numerical number 13 is a steel wire of 4 meter is stretched through 2 mm. The cross-sectional area of the wire is 2 mm square. If Young's modulus of steel is 2 into 10 power 11, find energy density of the wire, energy per unit volume. Second part, elastic potential energy stored in the wire. 3 minutes with you. Yes, given is what? Length. Length of the wire is, yes, 4 meter. Increase in length delta L, 2 millimeter, 2 into 10 raised to power minus 3 meter. Extension is given. Cross sectional area of the wire is 2 mm square. Area 2 into 10 raised to power minus 3 meter square. 2 into 10 raised to power minus 6. Young's modulus of steel is also given. How much? Yes? 2 into 10 raised to power 11 Newton per meter square. You have to find out what? A part. Energy density. Energy per unit volume. You can write this as 1 by 2 stress into strain, or can you write it in terms of Y? Stress is equal to Y into strain. Stress is equal to Y into strain. If you put this value, stress is equal to Y into strain, this is 1 by 2 Y into strain square. Put values for the same. Strain is what? Delta L by L. Put values for Young's modulus, which is how much? Young's modulus is 2 into 10 raised to power 11. Delta L is 2 into 10 raised to power minus 3. L is 4. Calculate, come out with the correct answer. Yes? 2.5 into 10 raised to power joule per meter cube. Second part, try B part. Energy stored is how much? This is energy stored per unit volume. B part is elastic potential energy stored. Energy stored. Energy stored will come out to be what? Energy per unit volume into volume. Yes. What is the volume of the wire? Yes, area into length. This part, first part is how much? 2.5 into 10 raised to power 4. Volume is what? Area of the wire into length of wire. Area of wire is 2 into 10 raised to power minus 6. Length of wire is 4 meter. Put these values. Calculate. Point